everyone. Today I will be presenting my project on developing DynamicTales, an interactive fiction generator. This project explores how we can use AI to generate compelling narrative continuations and choices for interactive storytelling experiences. The motivation to choose this topic is simple for me. I loved to play interactive fiction games, like what's shown in this picture. It was created with platforms such as Orange Light, a popular interactive reading community in China, offer players choices that lead to different narrative branches and endings. However, these games are fundamentally limited by their pre-written nature. All possible passes must be explicitly authored in advance. This creates two significant problems. The first is a tremendous workload for creators who must write every possible pass. The second one is a restricted player agency, as choices are limited to what was pre-authored. My project addresses these limitations by developing an AI-powered storytelling tool that generates a dynamic, responsive narrative content in real time. This approach creates a more immersive and flexible experience while reducing the authoring burden, a perfect application for deep learning techniques. Previous work includes AI Dungeon, which is a small game that uses GPT models for open-ended text adventures but lacks structured narrative arcs. Novel AI focuses on creating writing assistance rather than interactive gameplay. Several papers like this one demonstrated hierarchical story generation, but not in interactive format. Another paper proposed planned write framework for coherent storytelling without player interaction, and several commercial games like Fallen London and what I mentioned before, Orange Light games. They still rely on pre-authored content rather than dynamic generation. For training our models, I used public domain literary works from Project Gutenberg, focusing on genres relevant to interactive narratives. These include classic literature, detective fiction, and adventure stories. I processed them into training segments of 100 to 1,000 characters. These segments provide the context continuation pairs needed for training our models to generate coherent narrative continuations. To evaluate models, I selected four key metrics: perplexity, which measures how well a model predicts text; blur score, which measures text similarity to reference text; vocabulary diversity, which captures the richness of generated language; response time, which is critical for interactive applications. These metrics provide a balanced assessment of both the computational performance and creative quality of the generated text. My data pipeline consists of four main steps. The first one, data collection and pre-processing. The second one is feature extraction, which creates vocabularies, extracts n-grams, and prepares context continuation pairs. The third one is model training across three different approaches: naive machine learning and deep learning, and the last step is evaluation. I implemented three different approaches. First, a naive model, which uses no machine learning but simply fills predefined templates with randomly selected entities. This serves as our baseline. Second, an n-gram model representing machine learning approaches. This statistical model captures local patterns in token sequences but has limited understanding of broader text. Third one is a transformer model, which uses the GPT-2 architecture, fine-tuned on our story corpus. This represents the deep learning approach with its ability to maintain longer-term coherence. In comparing performance across all models, clear patterns emerged. The transformer model consistently produces the most coherent and diverse text, but at the cost of slower response times. The naive model was extremely fast but produces repetitive and often incoherent text. The anagram model offered a reasonable balance, generating text of acceptable quality with moderate response times. This comparison highlights the trade-offs between quality and performance that are critical in interactive applications. Now, demo time. Demo in action. This interactive fiction generator allows users to start new story, and here we can choose our starting scenario. For example, I choose you wake up in a strange laboratory with no memory of how you got there, and we click begin adventure. Here we receive the objective, that is discover who you are and how to escape the laboratory. And users can receive narrative continuations based on context like this, and we can choose from generated action choices. For example, we choose like the first one, and the model can return the next steps, the next continuations, and we can continue to choose the next step, like follow this, or we can write my own action like leave now and submit it. And this is my demo, my DynamicTales, and hope you like it. Let's wrap up here. Our evaluation confirms that the transformer model produces the highest quality narrative continuations with the best coherence and diversity. However, the anagram model offers a good balance for resource-constrained environment. Response time continues to be a challenge for real-time applications. And here is the ethics statement. Generated content can perpetuate biases, presenting training data, and potentially producing inappropriate content. But mitigations implemented careful curation of training sources, content filtering for problematic outputs, and clear disclaimer about AI-generated nature. That's all for my projects. Thank you for listening.